So if I have like, I can write something. Okay. So I have cards. If I have cards in a row like this, yeah, I wanna prove. By the way, Ernest, did you prove this? Oh, okay, so you can maybe check it against what I. Okay, so when you wanna prove something, okay, it's not the same as solving the problem. Okay, it's very different. Solving the problem is like it's like you talking to yourself with a scratch paper. You understand?
Yeah.
Like what you do is all just for yourself to see. Okay. When you write a proof, it's for other people to see. You understand? So you can't assume they know anything more than what's in the question. You understand? You can't assume they can read your mind. Okay. Alright. And I think it's also a good writing practice to tell people right away what the ending is. You understand? So this is not the same as like storytelling where you want to kind of hold suspense, you know, like and deliver a punchline or something, okay? Because a lot of people they want people to appreciate how clever they were when they solved the problem. So they kind of maintain the punchline till the end and they're like, "Oh, I solved it." Okay? That's not what you want to do when you're writing a proof. Okay? So if you're writing a proof, then what you want to do is say the ending at the start. Okay? So you want to say, for example, so illusionist. So I'll call the illusionist like, so illusionist wins. Oh, maybe I is for I as well. Win. Yeah. If and only if. Okay. So if and only if the three of clubs, I'll call it 3C because I can't draw clubs very well, is on one of the ends, yeah? Or you could say like first or 52nd card from the right, from the left, yeah? Okay, or end of row. You really write a full sentence, but I'm kind of trying to write less because my mouse is not great for writing on this. Okay, so I want to prove that, yeah? So what that means is if it is on the end, I need to prove I can win, and if it's not on the end, then I prove the illusionist can't win. Okay? This is illusionist here. This illusionist is I. Yeah? Okay. So can you see why the illusionist can win if it's on the ends? So if it's on the end, right? So if the card's on the end, why is it that they'll win? Do you know? Why?
Because if you select that card, you can just go on the other side and do the last one. Select a different card and go on the opposite end.
Yeah.
And
Okay, so basically, okay, so if the card is on the end, okay?
yeah.
So you gotta state some stuff. So if the card's on the end, then if it doesn't get picked, it's gonna stay on the end for the rest of the time until the end, until it's either picked or you win, right?
Yeah.
Okay, and if it stays on the end the whole time, the only way to pick it is to pick the number 1, right? Or the number 50, whatever the number of cards you have left is, right? Okay. But if they pick 1 or the other number from the other end, you can always pick it from the opposite end, right?
Yeah.
And you can do that all the way down to there's only 2 cards left, and then you do it one more time, and the 3 of clubs is left, right?
Yeah.
So that proves that you can win with the 3 of clubs. Okay. So if you want to be a bit more clever, you might come up with a statement that, for no matter how many cards there are, you can't pick the 3 of clubs if it's on one of the ends. Yeah. Because then that statement will change with the situation, right? Whereas if you just state it for 52, you have to figure out what happens for 51, 50. Yeah? Okay. Now what happens if 3 of clubs is not on the end? Yeah? You see? So if it's like, instead of on the end, it's like here, a third of the way here. Yeah? Let's say it's in position A. Okay? What do you do then?
If I'm picking that number,
Mm-hmm.
then you eventually do this thing.
Yeah, so you can keep picking A, right?
Yeah.
And it'll force people to keep taking A from here, right?
Yeah.
Yeah? And eventually it'll have it so that you'll have this many cards left, and then it'll be in the middle, and if you pick A, then it'll have to get picked, right? Okay. Is that a complete proof?
I think.
So it's not a complete proof because what if your A is like 2/3, you know, like what if your A is like instead of at the first third, what if it's like over here, right?
And if you choose the other side.
Yeah, so if you pick A now, you take it from the other side, right?
Yeah.
And the other side is going over here now, right? Yes? Okay. So you have to take care of both cases, okay? But a nice way to take care of them both in one case is to just pick A to be from whichever side it's closer to, right?
Yeah.
Because then it's always in this, it always can be argued like this then. Because then if A was over here, then you just take it from the right instead of the left.
Yeah.
And the same argument applies. Do you understand?
Yeah.
You understand? Michelle, do you understand? How could you understand? You're not trying, you're not listening, you're not watching, you know? It makes no sense that you would understand. Can you put your other stuff away and focus? Yanni, do you understand? Lucas, does this agree with your proof?
Yes.
Huh? It does?
Yes. I just
Okay, good. Yeah, so I mean, it's the first question in the Tournament of Towns. It's a bit more lenient on proofwriting, I feel, because I want to encourage beginners, um, but when you get good enough and this kind of problem becomes easy for you, then you want to emphasize more the proofwriting, right? Because you got to try to work on something. It's not practice. It's never practice. It's always learning. Okay, you understand? Even in basketball, it's called basketball practice, but like literally, like none of the things we practice are things we actually know how to do really well, are they? So we're actually learning how to do them really well. Whereas practice is more like repeating, right? It's kind of it's not quite the right thing.
Sort of like getting used to it.
Yeah.
Hello?
Hello, Aiden. Can you hear me?
Yeah.
So we just went through the first problem there. Um, if you want to see it, you can rewind on the live stream. I'll put it here.
Alright.
But no, we're just moving on to the next problem right now. If you can join the live stream but stay on Zoom, that'd be good.
Yeah.
Okay, yeah, so the Tournament of Towns is on Saturday, November the 4th, Aiden. Yeah? Let me know if you can
Yeah.
make it.
Alright.
Okay, so whereas that was the first question, this is the fourth question, but it's still a question that you could probably have a lot of fun with. See, if the geometry came up with the fourth question, you'd probably have no chance, but a question like this, it kind of still gives you a chance because it doesn't require you to know anything, right?
Yeah. What we doing with Lincoln?
Yeah, but did we solve it?
Yeah, because I don't have time.
Yeah. Okay, I might put a time limit on this because Lucas has already solved it. And yeah, so hopefully Yanni can stay to 7 today. Um, yeah, we'll try to cap this at, yeah, it should not go for more than half an hour. So try to understand the question.
The answer is yes.
I understand this question.
Okay, now try to figure out how to do it.
You don't know. It's like balance.
Hmm.
There's a light one, two fake ones, a lighter one and a heavier one. Um, is a heavy one still more heavier than if it was a normal one, or does it like does this type of scale only tell you which one's heavier, or does it tell you heavier by how much? Like,
Oh no, it doesn't tell you how much heavier it is.
how much heavier as in
Like it doesn't tell you the difference. Yeah. But the fake coin, the lighter fake coin is lighter than the real coin by the same amount as the heavier fake coin is heavier than the real one. Okay?
So like I was thinking like there are two fake coins and one is like heavier. The heavier one is heavier than the one was lighter and then
Yeah.
but I don't know the portion between.
This is cage and this is the bouncer.
Yeah, you can't detect that. Yeah, like you can't tell the difference between heavier versus fake light one and heavier versus real coin. Yeah.
So
Yeah, I guess there's one thing I'd like to try before telling people the solution. I'd like to try if it's possible to do it with 2 coins versus 2 coins as the first weighing. Can you see the first weighing? Like it's kind of pointless to have like 3 versus 2 or 1 versus 2. You want like 2 versus 2 or 1 versus 1, right?
Yeah. Unless the heavier ones are like 3 times the weight.
Yeah, unless you know something more specific about the weights.
2 times the weight.
Right, so let me just think. If you have 2 versus 2, right?
Yeah.
Then what could the outcomes be? If they're equal, they can be equal, right?
The equals and the second.
So if they're equal, actually I'll just write the equal sign. So if they're equal, that should be best for us. It could be, well, you can't have 4 real coins, right?
Yeah.
So it has to be little fake, big fake, versus 2 reals, right?
So if 2 coins are the exact same weight, then you'll know they're both real. So you take one of them that's real and measure with all the other ones to see if they're the same
But
length.
you only have 3. You only have 3 tries. You can't do 4 tries. Okay? You don't have 5 tries. You
So
only have.
if you just measure one side, if they're not equal, then you know which one's faster and which one's heavier, and which one's big ones are. If they're equal, then you know those are the little ones, and the other 2 are the big ones, and then you just do another measure to see which one's heavier and which one's lighter.
Yeah, see. Perform 3 weighings, yeah?
3 weighings.
Okay, so be quiet. And then so if you have this, you don't know which one's which, right? And so Ernest, you were saying you can just weigh one of them against each other, right? And obviously the one that's not weighed is real, yeah? Okay, so this case is solved. So if you have 2 as 2 and it's equal, you're actually doing well, okay? Okay, but what if it's unbalanced, okay? If it's not equal. So if it's not equal, it could be a bunch of weird combinations, right? It could be like R and F is lighter than RR.
Oh,
And obviously, because you're trying to guarantee the result, like you can basically assume you're gonna get a non-equal result at the start, right?
Yeah.
Because like
There's only one possibility.
yeah. Okay, so then it could also be like RF is greater than RR. And you could also get what else could you get? You could get some combination that doesn't involve all 3 R's, right? You could get like F R. You get FR is greater than little fr, yeah. No. So actually, you have to have 1 R on each side, right? So if you have to have 1 R on each side, then I think these are the only possibilities. No? Yeah, because there's 4 spots and there's only 2 fakes, yeah. So if you have two fakes on one side, then the two R's on the other side won't give it. It will make it equal, right?
Yeah.
There has to be one R on each side, and then it's just a matter of what goes with the R. It can either go with R, and then you have F and F on the other side, or it can go with an F, and the other side goes with an F as well, right?
Yeah.
So these are the only three possibilities.
So if it's big F R and F and R, that would be easier to solve as R F and R F or R F and R.
Yeah. Okay, so I guess one thing that you do know is that the greater side is going to be a big F and a little r, or a little r and a little r. And you know the small side is going to be a little r and a little f, or two little r's, yeah?
Yeah.
So if we weigh the smaller side, for example, yeah?
Yeah.
And we get that they're equal, yeah?
Yeah.
Then we know it's two little r's, right? Okay, so if we're the small side and the equal, then it's two little r's, and then the bigger side has to be r and f, and then the other one has to be an r, right?
I found a way. I found the answer.
If they're non-equal, then which one's the right one?
So if they're not equal, then the heavier one's the r, right?
Yeah.
The lighter one's the little f. Yeah, and we're in one of these cases, right?
And also, therefore, making the last one a fake one.
Makes the last one a fake one.
You have no idea.
Um.
And then you went with the other one, then you see it.
Yeah.
And you see awesome.
Okay, so then you can measure the. So yeah, so if they're not equal, then you one of them's little f and one of them's r, and you know which one's which, right? And you have one weighing left, yeah? So then you weigh the other side, and then you can tell the other side is if it's RR or FR, right? And if you know what's on the other side, then you know what's left as well, yeah? So then you win. So actually it does work if you do 2 versus 2. So the reason we didn't consider 2 versus 2 at the start when we did this problem the other day is because I think 2 versus 2 puts more combinations into, like having more combinations in one go makes it harder to analyze completely. But it still seems to work. So that's why you might go with 1 versus 1, because it puts fewer combinations in each case. And that's one of the reasons why when you play chess, people tell you when you're looking at the position to look at the checks and the captures first. Have you heard of that?
Yeah.
And the reason they say that is because they're forcing moves. So there's less combinations of moves that follow.
What if you try to check
But the point is, you know what happens after your checks, because they can only respond in very few ways, right?
Yeah.
Whereas if you make from random move, they could have like 25 replies. You make a check, they have like 3 replies, you know what I mean? It might not be the right move, but you'll know if it's the right or the wrong move very quickly, yeah? Alright, does this work? It seems to work, right?
Yeah.
I have an answer.
Hmm?
I have answer. For data.
What do you want to say? I don't think you really understand the question.
What I found out.
You also need to learn to talk properly. Okay, so Lucas, what was your solution 1 versus 1 first?
My solution was 3, 1, 1 versus 1.
Did you do 1 versus 1 first?
Yeah. Yeah.
Okay, so 1 versus 1. So if you do 1 versus 1,
My answer was.
so it could be equal, yeah.
My answer was weighing the first coin with the second, the third with the fourth, and then weighing the fourth coin with the fifth coin.
Yeah, so if they're equal, it has to be real versus real, right?
Yeah. Real. If it's not equal, it could be a combination.
If it's not equal, then it could be
any a
it could be little
combination.
f is smaller than r. It could be actually. So this one might not even be better for that because you have still three options, right? It's like little f is smaller than big F, and you have R is smaller than big F. Yeah.
So if we do, because I have the fourth matching with the fifth, I'm pretty sure it cancels it. It makes it so that we know which is which.
You speak up. I'll put the volume high. Hold on. You said it again.
So weighing the third and the fourth coin is the same thing, but weighing the fourth and the fifth coin makes it so it rules out the possibilities, and we end up with one possibility.
Oh wait, so this is we're weighing the first and the second coin. You're saying on the second weighing we should weigh the fourth and fifth coin?
On the second weighing, we should weigh the third and the fourth.
Oh, so two different coins than the ones you weighed at the first weighing. Is that what you're saying?
Yeah.
Oh, interesting. Okay, so that's a different answer than what other people came up with. So if we if we call this 1 versus 2, yeah,
Yes.
to mean first versus second, then you're saying do 3 versus 4.
Yes.
So 3 versus 4.
It has the
So
same answer.
are you doing 3 versus 4 if the first one's not equal? Is that what you're saying?
No. Wait, hold on. Are we allowed to like adapt?
Oh, you're allowed to do your.
Like, because if that's well, so what I mean by adapting is if one way if 1 and 2 are equal, then I can do like 4 and 5. But if 1 and 2 aren't equal, I will do 3 and 4.
Yeah, I think you can choose your weighings to depend on the outcome because, yeah, I think that's a natural.
I thought you couldn't.
Wait, so you can solve it even if you couldn't choose your weighings?
Yeah.
Oh, that's more interesting. Okay, look. So you're saying
So
weigh 3 versus 4 no matter what? Is that what you're saying?
yeah, you weigh 1 and 2 for the first weighing. You weigh 1 and 2, and then even if it's and then you weigh 3 and 4, no matter if it's equal or not equal.
Oh, that's great. Um, so obviously if the first two are equal, then this is not going to be equal, right?
Why?
Because you only have 3 real coins, yeah.
Yeah.
So
They
so
only have
3
real coins.
so they can't be equal at the same time because that'll give you 4 real coins.
Yes.
And then if can they be if they
can't be
equal.
If they can't be equal, since we have one big, one normal, and one small.
Okay, so they can. So they
They
one big.
can't be equal.
Oh, they can't even be equal. Is that what you're saying?
No, they can.
Yeah. If the first one is equal, then the second one can't be equal.
Yeah,
But if the
exactly.
first one isn't equal, then the second one can be equal.
And the second one probably can also be not equal, is that right?
Yes.
Okay, so the equal is easy. So the equal is just two reals, yeah?
Yeah. Equal is the same thing because we can't match small or big. So yeah, it can only be real and real. And for if it's not equal, well, then it would be the same possibilities as the first
Um,
one.
yes. And so that means like you can't have f is less than f for both of them. You can only have, so there must be one. Um, so that means, so if they're both not equal, then you can't have like f is less than f. You need like f is less than r in one of them, and f is less than r in the other one. R is less than f in the other one, right?
Yeah.
Oh, that's pretty good.
So both are the same, but I split it into groups. So the
Yeah.
first like case is that the first one or
Yeah, no, that's
or
very
one
good.
and
So
two are not. The first one is that 1 and 2 are not equal, and and 3 and 4 are equal.
yeah.
If we do
So
that,
yeah. So
yeah,
1 and 2 are not equal, and 3 and 4 are equal. Yeah. So
so
that
if
means,
we
yeah. Yeah, so that's probably the more difficult case, yeah? So the case where they're both not equal, we see that one of the, we actually know exactly what the four coins are, right?
yeah,
Because we know that oh, actually no, we don't know exactly what the four coins are,
we
but
don't.
we know one of them is little f is less than r, and one of them is little r is less than big F, yeah? So
Yes,
we know the fifth coin is real, yeah?
yes,
Um, but we don't know which one of the weighings has the little fake and which one has the big fake, yeah?
yeah.
Okay. Okay, so what's
So
your third weighing?
so my third weighing is for 4 and 5.
4 versus 5?
Yes,
Okay, but you don't know if, but are you doing it with the knowledge that 4 is heavier or is lighter than 3, or you don't know?
we know. So in the first case C 3 equals 4, which means they're both R. I'm just testing if E is bigger or smaller than D.
Oh, okay, so this is actually really fascinating, okay? So if you do 4 versus 5, okay? Alright, so 4 versus 5 is a little bit asymmetric now because we don't, what if, yeah, so he's, you know what he's claiming? He's claiming a lot more. So he's claiming that you can pick the weighings before you know the results, okay? That's a different level of difficulty than picking the weighings as you know the results, right? So
Yeah,
he's picking these weighings without actually knowing what the results are and still able to deduce the answer. Okay, so let's consider the case where, for example, that the first two are equal and the third and fourth one are not equal, right?
yes,
Okay, so if the first two are equal and the third and fourth are not equal, and you weigh 4 versus 5, yeah?
yes,
Um, it can't be equal, right? It has to be not equal.
yeah, it has to be
Okay.
not equal.
And then
So
4 could have been the heavier one or the lighter one. You don't actually. So
yeah, but
let's say if
still,
4 was the heavier one, okay, and it was heavier than 5, yeah? If 4
so
was the heavier one and it's heavier than 5, then 4 has to be big F, right?
Yes.
And then
And
3
since
has to
we know
be...
the first two are equal, since we know
Yeah. Wait, so you know the first two are real. You know 4 is big F. You know 3 has to be either little f or little r. Yeah? But then 5... Well, how do you know what 5 is? So now you... Huh?
fudge.
Yeah, so you might not know, but you do know that, like... So you know 3 is little f or little r, and you know 5 is little f or little r, right?
Yeah.
Yeah, because there's a symmetry between 3 and 5, right? So you shouldn't be able to tell the difference between 3 and 5 that easily.
Yeah.
Yeah.
That's the problem. Well,
Yeah. But still, if you knew if you knew what the heavier one was, the heavier one is either capital F or R, and you match it with 5.
actually might not be possible.
Yeah. But maybe you can pick the last weighing with knowledge of the previous weighings.
Because yeah, if that happened, then we know. I'm in class. So
So if you
if
weigh
we
the
had knowledge of the previous two, I would pick E. So I would pick. So we know that at least one is one of the two weighings is equal. Well, so I'm gonna pick one of the numbers from that equal weighing, and if
yeah.
E is bigger, then we know that E is big F. If E is smaller, then we know that
Ah,
E is
yeah.
small F. And if E is
Yeah.
just normal, well, then we know that the other two are
Yeah.
the
Alright, so what he's saying is if you take, because you know this is equal, right? So you can take, you know they're real, so you can take one of the real ones and then weigh them against either the heavier or the lighter one here, and you'll know exactly what it is, right? Because it'll tell you it's R. If it's greater, it'll tell you it's F, and if it's less, it'll tell you it's capital F, right?
What?
And so what that means is, um,
No,
so
I want to weigh it with E.
D,
I want to weigh the
the real coin.
one. No, I want to weigh the normal coin with number 5, which we haven't weighed yet.
Oh, okay, right. Okay, so he wants to weigh the real coin with the coin that hasn't been weighed yet, right? Which will tell you exactly what that coin is, yeah?
Yeah.
Okay. And then once you know exactly what that coin is, like for example, if it is capital F, right, then you know it can't be these last two options. So there has to be little f is little r in the 3 and 4. Yeah. If it's little f, then you can only see the little r. And so basically, the point is, no matter what the fifth coin is, it eliminates two of these three options, right?
Yeah.
And so that'll tell you exactly what that is. Okay, that's very good. Okay. And then the only other case to consider is if both are not equal, right? So both are, so one of them is little f is less than little r, and the other one is little r is less than big F, right? And in this case, what do you do?
The first two.
Say again.
First case is dumb.
First case.
Is the only one worth mentioning. And because
Yeah, so in the case where they're not equal, then you know the fifth coin is real, right? No, but you still need to deduce. You still need to use that real coin to make a weighing, so you know which one's big F and which one's little f. Yeah.
Okay.
Yeah. Okay, but that's pretty much it. Actually, very good. I still like the attempt. I mean, you can solve it knowing that it's dependent, and I mean the question still stands whether it's possible or not to solve it with the independence, but I think it's probably not that likely. Yeah. So the other solution was with I think the other solution. Yeah. So I guess this is like you do two weighings independently, and the third weighing is dependent. Yeah. The other solution had all the weighings were dependent on what was known at the time. Okay.
Yeah.
I think it was just one versus, so the first coin versus the second coin, and then you do it. You just figure out the cases, and then you just make up weighing based on the cases. Yeah. All right. Very good. So I'm gonna put up the next problem, but the next problem, I am a little bit afraid it's a little bit too hard for people. So I'm gonna take a break from that problem at some point, and also teach you something in between. Um, yeah, so geometry. Okay. So this problem. Okay, it's a little bit tricky, but I need you to have some idea how difficult the problems can be.
Even though it's not, I still don't really understand what Orthocenter is.
Yeah, okay. So Orthocenter is where the altitudes intersect. So if you draw a triangle, let's see. So if you draw a triangle,
Yeah.
you know what an altitude is?
Okay.
It's when you take one of the vertices and you join a 90-degree line to the base.
Yeah.
That's an altitude, yeah?
Yeah.
If you join all three, they're supposed to intersect at the orthocenter. Yeah. There might be a few things you need to know more,
So
but
like, it's like the place where all three of them meet.
yeah.
Okay. Um,
Alright, 3 more minutes and then I'm gonna tell you something, okay? Hmm?
does it work for right angled triangles?
Yeah, so the right angled triangle, the orthocenter is just it's on one of the corners, the right angled corner.
This would go here. This would go here. So it would just be this corner.
Yeah, exactly. The altitudes are just the side lengths. Okay, guys, let me just review some things just in case. Let's see if I can do that. Oops. Share screen.
Wait, I also have another question.
Yes.
So, like, if one of them is obtuse,
Yeah.
one of the angles is obtuse,
Yeah.
what would be the orthocenter?
That's a very good question. It's on the outside now. It's not on the inside anymore. Okay, so you guys know what similar triangles are?
Yes.
So let me see.
Illustrate.
So a triangles are similar if they basically look the same, but it's smaller or bigger. Yeah.
Yeah.
But if I put the sides like this, they're parallel, it makes that obvious. But what if like I rotated it, it doesn't look as obvious? Like what if one of them looks like this, and the other one kind of looks like this? You know what I mean?
Yeah.
Then it's not so obvious that they're similar. And so I guess our working definition for similar, okay, is that the angles are the same. That makes sense?
Yeah.
Because here, for example, okay, but it's not just that the angles are the same, it's that the sides are also in proportion. Does that make sense? So like, so whatever, like this could be like a third of the length of this side. This could be a third of the length of that side.
Yeah. Then all of them.
And then all of them have to be a third the length. Does that make sense? No. So one thing we know about parallel lines, this is maybe something you may or may not know. So basically parallel lines are lines which are going in the same direction. Yeah?
Yeah.
So if one line makes an angle of some angle with one of the parallel lines, right?
Then we'll make the same angle with the
Then it
other.
should make the same angle with the other parallel line, okay?
Yeah.
So this is actually in the like the year 7
And also-
curriculum.
and
It's
also,
called
like,
corresponding angles.
And also,
Oh, the thing's blacked out. Hold on, let me just fix that.
also,
So this is called corresponding angles on parallel lines are equal. Okay.
there's also like this thing where if there are two lines that intersect, then if one angle is a specific amount, then the angle on the other side is the same amount. If those lines are straight.
Like this, yeah?
Yeah.
Yeah. It's called vertically opposite, yeah? Okay. Okay, whereas the vertically opposite I think is pretty easy to prove knowing the angles add up to 180. Yeah. The corresponding angles in parallel lines is actually an axiom. Okay. Of course they can also be proved when we're talking about specifically like points in like the real plane. Okay? Alright. But this is essentially our definition of parallel, okay? Alright, so for example, okay, how else can we conclude triangles are similar if not for just the angles? Well, it could be that the angle is like the same, right? Yeah. But the lengths, so we know the angle here is the same, and we know that, so for example, if this is 1 and 1, yeah, then the blue triangle is 2, 2 with the same angle, right? Yeah. So basically, there's only one triangle which can complete this picture, right? That go on this side here, yeah. And there's only one triangle which can be completed here, right? And so, the triangles actually have to be the ones which are similar to each other, okay? Does that make sense? Because there is a triangle which makes that similar, Okay, you just double this triangle, and you'll get something with that property. Yeah. But since there's only one triangle that has that property, then it has to be this one, right? So then these two triangles are actually similar. Okay. So this one here, like if all the angles are the same, we might call it AAA or equiangular. Okay. And here we have the two sides and the angle in the between. We call this SAS. Okay.
Wait, so I have a question. So like,
Yeah.
if you put a line here and here, does that make
Yeah, and
all
here.
of the triangles similar?
That is a good question. Okay. So it means, so you're talking about the four triangles there, right?
Yeah.
Actually, that's something we're gonna do a little bit right after this. So it actually makes all four triangles similar to each other, but obviously each pair has a different. You have to change the angles. Okay. So you're talking like if you take the midpoints of the sides, right?
Yeah.
Yeah. Okay, that's very good. Yeah, I'll show you that with a drawing later. Okay. Yeah, and obviously the last way to see that they're similar. So if these were just the angles, it'd be like that, right?
Yeah.
If you also just had the sides, okay, the angles would also have to be forced. Once you know the three sides, there's no other way you could put the angles in, if that makes sense. So the angles are determined by the side lengths, yeah? Because like if you have one side length here and you have another one, you need to kind of swing it just right for the third side to close, right? At that length. And how much you swing is the angle that's going to be, okay? And so all three angles are determined by three sides. So if you know the three sides are in proportion, or if you know two sides are in proportion, the angle in the middle is equal, or if you know two of the angles are equal, which means all three angles are equal, right? Then they're similar. Okay? And so for example, if you have this kind of situation, right? And you take the midpoint, yeah? If you take the midpoint, then and you join them, okay? Can you see that because these two triangles are similar, yeah? These lines are actually parallel, right? Because this angle is equal and this angle is equal, right? So these lines are actually parallel. Does that make sense?
Yeah.
Okay. Another thing I want to show you is if you have a circle, okay, and you have a chord, okay, and you take a midpoint here, right?
Yeah.
So these are equal, and you join it to the center of the circle, okay? Can you see that that's 90 degrees?
Yes.
Yeah, why?
Because you create a straight line to the radius.
Yeah, so you join the radii. So one thing you can do, because the radii are the same, right? What you can show is, you can show these two triangles, this triangle A and this triangle B. They're actually similar to each other, right?
Yeah.
But not only are they similar, the lengths are actually equal, right?
Yeah.
So the factor is actually just 1, right?
Yeah.
So when that happens, we call them congruent, okay? And we might write something like A is congruent to B, yeah? That makes sense? The triangles, yeah. So similar, some people when they write similar, they write like this. And we have it like this is also for similar, yeah? So this is similar. This is congruent. So congruent means they're exactly the same. Similar means they're proportioned. Okay, one could be like scaled up. So they're in proportion means everything is the same as that, but it's bigger by a factor of like something. So it could be double. Everything's double. So like this triangle is similar to this triangle. It's the same triangle, but just stretched bigger. Okay? Whereas this triangle is congruent to this triangle. They're like identical.
Doesn't that mean the triangle can be congruent to nothing?
To nothing? Why? Wait, why you say technically? Stop saying technically. What do you mean congruent to nothing?
If you keep on making it smaller, eventually it will be nothing.
You mean similar to nothing, right? So that's a very interesting idea. Okay, but you got for it to work, you have to still keep it like small, right? Nothing, it won't even have angles, right? Okay. Yeah. So there's actually a thing called the point circle, which is sort of like your idea, but with a circle instead of a triangle, right? Because triangle is a bit harder to get. Like it's more natural to make a circle smaller, right? Yeah. But we're not talking about that today. But like, yeah, you have this an interesting idea, yeah. So yeah, because all circles are similar, you know. Anyway, so can you see the triangles are congruent, right? And so that means the angles are actually equal as well, right? So here we don't actually need to know they're congruent, we just need to know they're similar, right? But so the angle opposite this side, which is this angle, right, has to be equal to this angle now, right? But because that line is 180 degrees, yeah, then the angles have to be 90 degrees, you know? So that's one way to prove that it's 90 degrees. Okay. Alright. So let me take you back to the geometry problem. So this is only the second problem on the test, and this is like why I'm stressing like basically try the first problem, yeah? And you could see how hard the first problem was when it became geometry, right?
Yeah.
So when the second problem becomes geometry, it can get quite hard, okay? And one of the reasons it's hard is because most people in Australia don't really learn in geometry, okay? So it's automatically harder because it's geometry, alright? But in some sense, it's also easier because geometry is very limited in what can happen, yeah? So if you do know it, then there's only so many things you can do, right? But if you don't know it, then it's impossible, okay? So if you look at this problem, okay, I drew a diagram actually for you. So this is the diagram, okay? So remember what the problem is saying? The problem is saying if you have a circle with center O, okay? And you took A and C, just some random points on the circle, right? You fix them, yeah? Then no matter where you move the point P, okay? If you take X as the midpoint of AP and Y as the midpoint of CP, then the triangle OXY will always have an orthocenter which doesn't move with P, yeah? Okay. So if that's the case, yeah, so how do you start this problem? Well, I think a good way to start the problem with drawing diagrams is try to figure out what that point is, yeah? And what you can do, because it's meant to be the same point for all the values of P, right? You can literally put P like up here or somewhere really nice or down here, yeah? And then you can sketch it so that you can find out where H is, okay? Actually, it turns out H should be the midpoint of AC, which is actually what you get if you let P equals A or if you let P equals C, okay? And so you're actually allowed to let P equals A or C, okay, which is kind of nice. So that's the point you would suspect first, because letting P equals A and C would be the easiest, yeah? But it might not be allowed, so if you move it a little bit, it might change, but you can see it shouldn't change by too much, right? Because if you move it a little bit off A, then the midpoint of PA should roughly just be A anyway, right?
Yeah.
And the midpoint of PC should be roughly M anyway, yeah? So And then the orthocenter, it's an orthocenter of a right angle triangle, which is the base, you know? Okay, so how do we prove that? Now that we know what it should be, how do we prove it? Okay? So it's much easier to check the orthocenter is the orthocenter than it is to find the orthocenter, right? So once you know this is meant to be the orthocenter, you just need to show that the line MX is perpendicular to OY, yeah? Because then you know it's an altitude, yeah? And then you can show the line OM is perpendicular to XY, yeah? Does that make sense? Okay, so... Oh, by the way, Lucas, have you solved this problem?
Nope.
No.
Code.
Mm-hmm. What did you say, Lucas?
I
Did you
said
say yes?
No.
Okay, if
I
you say
said
no...
No.
Okay, so maybe I'll give you, like... So now that I feel like we know all we would need to know, I'll give you, like, a few minutes to see if you can solve the problem, okay? So now that you basically know...
It's in your diagram, M is H.
Yeah, M is H. How can you prove it? So how can you prove MX is perpendicular to OY? How can you prove that OM is perpendicular to XY? And you don't actually need the third thing, but you can also show that then you don't need to know that orthocenter exists, because then you can just prove that OY is perpendicular to OX. Yeah. I'll give you at least 7 minutes. Okay.
What's the question?
You want to show that MX is perpendicular to OY. Okay. You want to show OM is perpendicular to XY.
If M is the orthocenter, wouldn't it?
But it's not. We don't know it's the orthocenter. We're trying to show it's the orthocenter. Okay? We just know it's the midpoint at the moment.
Is it a coincidence that M, A, and C
Coincidence?
is a
I don't think so. I mean, it's the kind of like the point of the problem, you know? So you get 6 more minutes and I'll tell you.
um, use the orthocenter X and Y. Y is the orthocenter X and three is X. Set truth. I think that is
Focus on this. So I already told you people that if you have a triangle and you join the midpoints, these lines are parallel, right? I already said that. Okay, and I already said that if you have a circle and you have a chord and a midpoint and you join to the center, this is 90 degrees. Yeah?
Oh,
So
oh,
I think part of your job is to recall the relevant facts. You like that picture?
Yes.
So what we're trying to show is that this line is at 90 degrees to that blue line, okay?
Oh.
And that's what we're trying to show.
It is 90 degrees.
Yeah, it looks like it, but how do you prove it?
Oh, yeah. Because it's the right angle.
Mm. Alright, 2 more minutes.
so you're saying if you place A and C anywhere on the circle, then it would be the same answer. So,
Yeah, I mean A and C can't be like diametrically opposite.
It is 90 degrees because it's
Oh,
the
maybe
right
it could
angle.
be.
It is 90 degrees because it's the right angle.
how do you tell it's right? That's the question.
No, they're not saying anything.
Mm.
What's the center?
Alright, 1 more minute. Okay, so here we go. Can you see this? So I want to show this angle here is 90 degrees, yeah?
Yeah.
So that makes that an altitude, yeah? Okay, why is that? Okay. Can you see that this angle here is 90 degrees?
Yes.
Because that's this situation here, right?
Yeah.
With y as the midpoint, that's y, yeah? You see? But see, this red line here is actually parallel to this line. Because it's going through 2 midpoints. You see that? That's this situation here. Yeah? So then it makes the same angle, right?
Yeah.
So it's also 90 degrees. Yeah? Okay, now that I've told you that, do you think you can see why it's the altitude, why OY is the altitude, why MO is an altitude and why MY is an altitude? Can you tell me that? So we just showed that MX is an altitude, right?
Yeah. Does that also make OX and XY an altitude?
Of something else, of another triangle. but I want to know MO and MY. It's an altitude of the blue triangle. Okay.
What does altitude mean? Altitude mean?
I already explained what altitude meant. It means if you have a triangle, one of the each vertex is an altitude which goes from the vertex, and there's 9 degrees to the base. Okay. So again, I'm gonna say this again. Okay, with definition questions, you gotta ask them when the definition appears. Okay. If you ask them like 2 hours later, it makes people really annoyed. Okay.
Yeah.
Okay, so can you see that this, we're trying to show, for MO to be the altitude, right? We need MO to be 90 degrees to XY, yeah? That's what it means for MO to be the altitude, yeah? But can you see that MO is 90 degrees to AC, yeah? Because that's this diagram again, right?
Yeah.
Okay. But MO but AC is parallel to XY, you see? Because of this.
Yeah.
Because the X and Y are the midpoints, right?
Yeah.
So that means MO is perpendicular to XY as well, because it's perpendicular to something that it's parallel to. Yeah?
So if you keep on using those two formulas,
Yeah, so I want you to tell me why MY is an altitude. Yeah? Can you tell me why?
um, basically the same difference.
Yeah, but you gotta explain it exactly what for this case.
So
we want to show MY is perpendicular to OX. Yeah?
so first we know that AXO angle is a right angle.
AXO is a right angle, yeah? Yes.
First AUP is parallel to MY.
Yeah. So it's like this and this again, right?
Yeah.
Then it makes the same angle with the line that it's parallel to,
Yeah.
right? Okay. Alright, one thing I should mention, but it's a bit beyond you guys at the moment. Whenever you have an orthocenter, whenever you have 3 points, so here OXY, the orthocenter is M, yeah?
Yeah.
So you have 4 points, yeah?
Yeah.
Whenever that's true, you have 3 points and one of them is the orthocenter.
Yeah.
You can literally replace the 3 points with any of those 3 points, and the other point will be the orthocenter.
Yeah.
Do you know what I'm saying? So,
Oh yeah.
Wait,
so
what?
if I instead of hello,
Wait, what?
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 Lucas. Hello.
Oh, I'm unmuted.
Who's muted? Am I muted?
I was unmuted.
Unmuted.
I was unmuted.
Oh. Okay, so literally, like, you can replace, so if you take a OMY, yeah, then X is the orthocenter of OMY. Because, remember, this is 9 degrees, so it's the altitude of that way, right? And this is 9 degrees, so it's the altitude that way. And this is 9 degrees. Yeah? So this is called an orthocentric system. We won't go into that anymore, but I want to mention it just in case you got that, okay? Alright. Now I want to do some cool GeoGebra stuff. GeoGebra.
Wait, is that an app?
Yeah. Okay.
Wait, I actually have an app like this on my school Wi-Fi.
Okay. So I want to talk about what So this is what Ernest was talking about, right? You take a triangle, yeah? Yeah. So I'm not gonna prove these things to you, but I'm gonna draw the diagrams, okay? So you take the midpoint. Where's the midpoint? There's a midpoint thing. Okay, I think the midpoint. The midpoint tool. Yeah. Yeah. So I take midpoints. Okay. I don't want to do that. I want to put D as here. D is here, yeah. E. Okay, I put the midpoints, right? That's what you were talking about before, yeah. So this triangle is called the medial triangle. Okay.
Medial triangle.
Medial triangle.
I've
Okay.
seen that triangle before.
Okay. So not only is it similar, it's actually similar to the original triangle, okay? And the reason it's similar, you might be able to see is because the angles are basically, see, because this angle is basically, that's the same as angle B, right? This is the same as angle C, and so that must be angle A, you know? And so they have the same angles, but let me just draw some more stuff. So join these lines together. These are called the medians, okay? So remember how we had altitudes? These are now medians, yeah? And you actually find something kind of cool. The medians actually are also concurrent. Okay. Do you? They're concurrent at the centroid. It's kind of crazy how it automatically labeled G right there. Okay. Yeah. So how do we do this? Yeah, eventually. We can do it whenever you want. So
I do it right now.
I think you should just listen right now, okay? Because you've had like a long time to follow instructions and you haven't. Okay, so yeah, so how do we I want to show that the way in which this is similar is actually quite crazy, okay? So you can actually flip the big triangle about G, okay? And then lengthen it by half, shrink it by half, yeah? And you get DEF. Okay. How do I explain this? Distance or length? Distance, yeah? You can make this distance here is 1.8, yeah? Alright, this distance here is 3.6. You see that?
Yeah.
It's literally double the distance. This distance here, 2.1, okay? This distance here, 4.2. This distance is 1.8, okay? Let's see if I can move that a little bit. Okay. And then, what was the distance thing? Distance here is what? I don't want that. Distance 5. What? 5.5. What's going on?
What's G plus C?
3.6, yeah? So basically, the thing is this triangle yeah, is the big triangle. It's similar to the big triangle, and it's similar in a very specific way. Like, you basically double it, and then you flip it about G. Yeah? So, this might be called a half turn, I guess. Half turn. Maybe another way of saying this is you're rotating it about G. Yeah. Okay. So that middle triangle is similar to the big triangle, right? And then we knew before that the smaller 4 corners is similar to the big triangle, so they're all similar. Yeah? That's what you were saying. Okay, very good. There's another fact I want to show you is kind of cool. So if I got, so this is very visual, right? So I've got another 3 points, make a triangle, yeah? Let me just save this. And then I'll make another one. Okay, so if you have points A, B, C, yeah? And then we draw a circle.
Circle between points.
Yeah, there's always a unique circle with 3 points, okay? So that's a circle, yeah?
Yeah.
Okay, so now let me do the orthocenter. So to get the orthocenter, I might want an altitude, okay? So altitude perpendicular line. Okay, perpendicular line, yeah? That's a perpendicular line right there, yeah? Alright, so then this point is called H, yeah? Okay, let me hide this. Maybe I can call this point something. I'll call this point, it's D. Oh, oops. I'll make point here, here, and here. Actually, it would have been easier if I just didn't make these points. I make this point first. D, E, F. And that would be G, but I want to change it to H, yeah? Okay, then I want to hide these lines. I want to hide this line.
You go to edit, and then say show hide object.
Where?
Show hide object.
Oh, very nice. Yeah. Okay. Then I wanna do. I don't want the whole line. I just want the segment. Yeah. Okay. Now let's take midpoints. I take the midpoint of BH, yeah? The midpoint of AH, yeah? Midpoint of CH, yeah? Then I take the midpoint of AB, yeah? Midpoint of CB, and take the midpoint of AH, yeah? Okay, so here's a pretty crazy fact. If I take all those midpoints, okay, and I take the altitude foot, yeah? So where D is the foot of the altitude, okay? Okay? This is visual. You should basically be staring at this and listening to me. You shouldn't be looking at the window, you understand? Okay. Can you see that actually all of those points lie on a circle? Okay?
Yeah.
So this is called the 9-point circle. So if I was to put a circle through 3 points. If I pick 3 points like D, E, and L, the circle actually goes through all the points. See that? That's kind of cool, right? Yeah. Okay. Okay.
How can I access Geogebra?
You can do it after the lesson.
Okay.
Everything you say is just distracting, you understand? And annoying.
You said everyone here is distracted. What about me?
No, I'm talking about someone in particular next to me, distracting me. Okay, so another thing that's kind of cool about this diagram, okay, is do you remember when I said that the other triangle you could flip it and double it and it becomes the other triangle?
Yeah.
Well, here, this crazy circle, you can actually double it and it becomes the other circle. Okay, so let me show you. So how do I do this? I need to reflect about there and there. Okay. And then do I have a reflect about point? Reflect. Reflect. Where's reflect? Reflect around a point. Reflect. So look, reflect about K just means I put the same length from H to K as to K to this other point, okay? But watch, it lands on the circle, okay? Isn't that cool? So I reflect the point, it lands on the circle.
There's 2 H's and 3 H's.
Yeah.
Technically, there's only 1 H.
I know, but there's
There's 3h factorial.
And it's 2 comma h's.
That's h factorial. What's it called again? H prime.
That's kind of cool, right? So if you just take some random length, distance, yeah? So here we take this distance here. It's 2.6. It's 2.6, see? You could take another distance. What's something that's not obviously twice the distance? Like, obviously the midpoints.
A to B.
A to B is not. It's all from H. So I'm saying this doubling comes from
A
H.
to H.
H to I.
No.
I to A.
But I is defined to be the midpoint, so it's kind of obvious they're equal. Yeah.
A to H.
So it's really these reflections, I guess, that are not as obvious.
A to H.
So here.
Well, N to H.
N to H. Yeah, N to H is one of them. It's a bit. No, not space.
How about H to H?
See, this is 1.9 here. And this is 1.9 as well. Yeah. You can see that's pretty crazy, right? You have 9 points, they all happen to lie on a circle. And then they all reflect. They all double, so they're similar in this very specific way, right?
Yeah.
Are you coloring?
Yeah. Kind of just to make it stand out a little bit more. Huh? Yeah.
Isn't this the same circle as I saw before?
Not quite.
But it looks a bit like the circle. Yes. Because it is a blue circle with random lines that have green. Right.
Alright, do you guys have any questions?
I have a question.
What?
Can you make, like, you know, the H thingies to any letter? Like the comma apostrophe thing next to any apostrophe thing to any letter?
Yeah, I think they just make, when this program does reflection, it just puts apostrophe. Alright, that's it, guys. Thanks for joining us.
Oh, my dad. Yeah, that's my dad. I can sort of tell the squash.
Hi, I'll send him down.
See, I can recognize his voice though.
Is it a bing?
Alright, have a good week, Aiden, Lucas.
Alright, see you next week.
Alright, see you next week.
Yep.
Now, can I access you?
Yeah, you can.
Yay! How many people? Stop yet because the live stream isn't over.
No, it's not over yet.